Welcome to Computer Vision for iOS Developers course. I'm Alex Korotkov, founder and CEO at MakeML, a macOS app allowing iOS developers to train object detection and semantic segmentation neural networks for mobile. I've developed several iOS apps with computer vision, so I understand entirely how much pain it takes for a developer to start working with machine learning. That's why I founded MakeML, and in this course I'd like to show you everything you need to integrate computer vision neural network into your app, from collecting dataset to processing model output. Here is a list of key topics that we will cover. At the end of the course, we will create two projects from scratch. One of them will be a dribble app that detects the number of touches of the ball, and another one will be potato computer vision scales. These two projects are actually real-world applications. DribbleUp.com uses one, and PepsiCo uses another. There are no special prerequisites needed for this course, except for your enthusiasm. I will try to explain complex topics as efficiently as possible. Feel free to study the course contents below, and I'm looking forward to seeing you on board. Hello, it's Alexei, and in this video I'm going to make a gentle introduction to computer vision. Computer vision, often abbreviated as CV, is defined as a field of study that seeks to develop techniques to help computers see and understand the content of digital images, such as photographs and videos. It is a field that could broadly be called a subfield of artificial intelligence and machine learning, but also it may involve the use of other specialized methods. Computer vision as an area of study can look messy, with techniques borrowed and reused from a range of different engineering and computer science fields. For instance, one particular problem in computer vision may be easily addressed with a handcrafted statistical method, and another may require a large and complex ensemble of generalized machine learning algorithms. The goal of computer vision is to understand the content of digital images. Typically, this involves developing methods that attempt to reproduce the capability of human vision. Understanding the content of digital images may involve extracting the description from the image, which may be an object, a text description, a three-dimensional model, and so on. You also need to distinct image processing from computer vision. Image processing is the process of creating a new image from an existing one, typically simplifying or enhancing the content in some way. It is a type of image processing and is not concerned with understanding the content of an image. A computer vision system may require image processing to prepare image for some further manipulations, and this is called pre-processing. But if you are not trying to get some data by understanding of an image, it's not called computer vision. So some of image processing examples are changing brightness and color of an image, cropping the bounds, or applying some filters. Let's talk a bit about computer vision challenges. Helping computers to see turns out to be very hard. Computer vision seems easy, perhaps because it's so effortless for humans, and initially it was believed to be a trivially simple problem that could be solved by a student connecting a camera to a computer. But after decades of research, computer vision remains unsolved, at least in terms of meeting all the capabilities of human vision. The reason why it is such a challenging problem is because of the diversity and complexity of the visual world. A given object may be seen from any orientation in any lighting condition with any type of occlusion from other objects and so on. A true vision system must be able to see in any of an infinite number of scenes and still extract something meaningful. Basically, computers work pretty well for tightly constrained problems, but not for open, unbounded problems like visual perception. So let me name you a list of some high-level problems where we have seen success with computer vision. Many of these applications involve trying to recognize things in photographs. For example, object classification, what broad category of object is in this photograph. Object identification, which type of a given object is in this photograph. Object verification, is the object in the photograph. Object detection, where are the objects and their bounds in the photograph. Object landmark detection, what are the key points for the object in the photograph. Object segmentation, what pixels belong to the object in the image. So, in this course, we'll dive deep into understanding of how to train object detection and object segmentation models and run them on iOS devices. Hello, it's Alexei, and in this video I'm gonna tell you what applications can be made by utilizing object detection and semantic segmentation. We are talking about object detection and semantic segmentation here because in this course we'll learn how to train both of these model types. So the first, and I think everybody knows this application, is face detection. Popular applications include face detection and people counting. Have you ever noticed how Facebook detects your face when you upload a photo? This is a simple application of object detection that we see in our daily life. The second application is people counting. Object detection can be also used for people counting. It is used for analyzing store performance or crowd statistics during festivals. These tend to be more difficult as people move out of the frame quickly, also because people are not rigid objects. But it is used quite broadly. The third application is vehicle detection. Similarly, when the object is a vehicle, such as a bicycle or a car, object detection with tracking can prove effective in estimating the speed of the object. The type of ship entering a port can be determined by object detection, depending on shape, size, etc. These systems for detecting ships are currently in development in some European countries. This vehicle detection is also used broadly on motorways and on entrance to the cities. One of the most famous application of object detection and semantic segmentation is in the automotive industry. Technology giants like Google and Tesla are working on a full-fledged self-driving car, and features like Tesla's autopilot are available by using both object detection and semantic segmentation to understand what happens around the car and what are the borders of other objects or vehicles on the road. Object detection and semantic segmentation also has their applications in marketing. Social media platforms are a fountain of images and videos. Up to 95 million photos and videos are uploaded to Facebook daily. Handling and processing such massive volumes of data manually is not possible. Computer vision can process images automatically, finding brand logos quickly, finding optimal color patterns for different targeted markets, and searching for the subject of pictures. Computer vision can allow companies to cater towards targeted markets in a more personalized manner. Also, object detection has some application in sports. In sports, computer vision can track the movement of players and the ball. More complex game analysis and insights be generated in real time to help improve player and manager performance. This improves game watching experience, accuracy of referees, and can lead to better player performance over time. Hello, it's Alexei, and in this video I'm gonna show you an overview of 5 the most easy to use and set up image annotation tools. As you know, to train a neural network, you need a dataset, and to create computer vision neural network, you will need to take images and annotate them. So, the first annotation tool that I want to cover in this video is Label IMG. Label IMG is one of the most popular tools for annotation, and it is written in Python. And you can install it on Linux, Windows, and macOS. Just you need to get master of this repository and start a search script, and then Label IMG will be installed on your desktop, and you will have something like this application. So I have opened a directory with images. So I open a directory with 2 images of cars. I have several bounding boxes previously, but I don't want to save them to show you how you can annotate images. So to create an annotation, you need to press W button, and you see some cross icon, and to annotate this car with bounding box, you just need to press left button and drag. So here you need to select a class for this annotation, which will be car. And on previous image we already have some annotation. You can drag it. So this image annotation tool is only suitable for creating bounding boxes, and you can export them. They by default exported as XML files, and it's looked like this. So you have a link to an image, and you can see bounding boxes here. Second image annotation tool that I want to mention is VGG image annotation tool. It's an open source, easy to use, independent manual annotation software. It can be used for annotating image, videos, and audio. It's written in HTML, CSS, and JavaScript, so it's very easy to run. Just open a website and you are ready to go. So for annotating images, you can annotate different shapes, like rectangles, circles, ellipses, polygons, points, or polylines. To load images, you need to press load or add images. You can do it like this, choose them. We have an annotation here already, and on this image, to add annotation, you also need to press and drag. So after this, you can save it as CSV or save it as JSON. The third image annotation tool that I want to cover in this video is label box. So label box is open here. After logging in, you see all your projects and datasets. To start annotating images, you need to upload new dataset. Select two images. You need to name your dataset. It will be cars. Start uploading them. Then you need to create a new project, which will be also cars. You need to attach a dataset that we have uploaded. Oops. So we can attach a dataset. Press dismiss, press next button. They have two different editors. We can select the regular editor, add object as a class, which will be car, and we want bounding box, also polygons, polylines, and points available here. We don't need classification. Confirm, complete setup, and we can start labeling images. We need to select an annotation title and also press and drag to annotate an image. Press one more time, then press submit and another image. So label box have a community version which is free, and you can annotate 5,000 images, and they also have enterprise version, and there you will receive some custom prices for it. Fourth annotation tool that I want to cover in this video is RectLabel. It's a macOS application. You can label here object detection bounding boxes and polylines for semantic segmentation. So you can download this app from the Mac App Store. To start, you just need to open folder with images and with annotations. Press OK. Then you just can press and drag, select annotation label. You can edit them. Then if you save changes, it will add XML files to the folder, which you have specified earlier. And you can export to different formats. Export as XML, export masks for polylines, export XML for CocoJSON file, and so on. The last but not least is MakeML. MakeML is an image annotation tool and also environment for training computer vision neural networks. You can annotate object detection bounding boxes here and semantic segmentation polylines. After downloading it from the App Store and logging in, you will receive some looking like this screen. To create a dataset, you need to press this button, name it cars, add annotation title car here, import images, and you are ready to annotate them. So here you can import images from video, import images, import some datasets of various formats. You can also export datasets to different formats. You can create and export 3 datasets using MakeML for free, and train 1 model using MakeML. This was the brief overview of 5 image annotation tools. Thank you. Bye. Hello, it's Alexei, and in this video I'd like to show you different tools and environments where you can train computer vision neural networks for mobile. So let's start with MakeML. To train a neural network using MakeML, we need to create a new MakeML project. We can select here dataset type, so the model could be object detection or semantic segmentation. We need to enter project name, pineapple. Here we can select a framework on which model will be trained. So let's select TensorFlow, press create. We need to import these images as I've shown in the previous video. Annotation title, adding annotations. Here we can change training parameters such as batch size and number of iterations, and we need to press train button to start training. Here MakeML proposes us to make some augmentation to the images, and we just need to press start training. So it archives a dataset, uploaded to the server, and the training will start. We can check training progress here. So here is an output, and here will be a graph showing the progress of training. Right now it's not started, it's just setting up of training. So when the model will be trained, we will be able to press export model button, and we'll receive a CoreML model that we can use in our mobile apps. So it's starting training. The model is training using powerful GPUs in the cloud, and for this you need so we can see that the loss is going down, and the loss is a parameter which is if less then better. So the pricing for MakeML has like 2 types, yearly and monthly subscriptions. With base pricing we can create object detection semantic segmentation dataset. We have 3 free experts and 1 free GPU cloud training. So also 2 training plans with unlimited GPU cloud trainings. Here we have a limitation of 5,000 images, and here we have a limitation of 15,000 images. So let's get back to MakeML. We will close this screen and to proceed to Creating ML app by Apple. we need to export dataset here in Creating ML format. We need to do this because Create ML don't have its own annotation tool, so we need to prepare some data for it. So we'll save our pineapple dataset to desktop and we'll close MakeML. So in MakeML you can also open trainings after some time, and the model will be trained. You'll see it. So to train a model using Creating ML, we need to create new document. Here is some different types of models that we can train. For computer vision, it's image classifier and object detector. We'll select object detector. So it's pineapple. We'll press next. We'll add this. We'll create this project at desktop. Here we need to select files with our dataset, which is pineapple dataset that we have exported with MakeML. We are ready to go. We can set maximum iterations here. And to start training, we just need to press train button. Creating ML is totally free, but the model will be trained locally on your machine, and it can train for a long time. Sometimes it's not using GPU, and yeah, it could take like 4 hours, 8 hours, like 16 hours if the dataset is big enough. So the model have started to train. We have 17 iterations out of 1000. Output will be here when the model will finish training. So my Mac started to work slower because it's very resource consuming. So we can check it here. Power usage. Creating ML app is here. So right now we'll stop this because it will take a lot of time, and we'll proceed to our next environment where we can train a model for computer vision for mobile. It will be Microsoft Azure. They have cognitive services, and a product of this, one of the products of these cognitive services is Custom Vision AI. So you can create an account in Microsoft Azure, then select cognitive services and create custom vision projects. And in this environment, we can create new projects. Call it pineapple. We can select here object detection. As a project type, they also have classification. Then we need to select general compact. It means that these models will be applicable for mobile devices. We can select here basic platforms, TensorFlow, CorelML, etc. And we need to create project. We can add images here. We cannot use actually a dataset. We need to mark them down here. Pineapple. Let's go to the next. We also cannot export images from this annotation tool. Here we can see our tagged images, and after we tag all the images, we can press train button and the model will start training. But we have less than 15 images in our data set, so it will say to us that you need to have at least 15 images for every tag to start training. We don't have this, and we don't have time to show all the pipeline. So the pricing for cognitive services is quite tricky to count sometimes when you are a beginner. They have a limit of 5,000 training images per project, 2 projects free, and up to 1 hour of training per month, and 10,000 predictions per month. So, but it's also can be useful to train a model using Microsoft Azure services. So the next service is the next environment where you can train your model is Jupyter Notebooks, and I'll show how Google Colab can run Jupyter Notebooks to train neural networks. So I have found some object detection demo project on GitHub, and I'll open this this Jupyter Notebook. It's something like a Markdown document which has some code and some text, and you can insert here links and some other stuff, and actually you can run this code one by one in Google Colab. So we have here a button, open in Colab, and it's loading right now. So here you can change all the parameters, like model configuration, number of steps, like you can change it here. You can have more control over the training of your model, but sometimes it becomes very hard because this environment, for example, cannot support some Python dependencies that you need to have to train a model, and sometimes the code is become outdated, and like Python version and dependencies are updated, and it can become outdated even in like 2-3 months. But still, it's an option that many machine learning specialists are using nowadays to train models, and it looks like this. So you press if you want to run this part of code, you press play button, and the code is running right here. So after this, you want to run this part of code, and you can run it, and it shows output here even. So this is completed, like the first one that was executed, this part of code, and yeah, and so you can train a model in Google Colab as well. The price for Google Colab actually is free, and they even provide some GPU resources, but it's not very clear how much do they provide, because they have shown that they have some resource limits and they can be flexible. And like notebooks run by connecting to virtual machines that have maximum lifetimes that can be as much as 12 hours, something like this. Yeah, the fifth, of course, you can rent an EC2 instance, and like Amazon AWS EC2 instance, and like set up Python environments and run training via Python, Python scripts and Bash scripts. But we think that to start off with computer vision for mobile, MakeML, Microsoft Azure Cognitive Services, or CreateML is much better options. This was a brief overview of environments for training computer vision neural networks for mobile. Thank you, stay tuned. Hello, it's Alexei, and in two previous videos we have reviewed different tools for creating datasets, labeling images, and another set of tools for training neural networks and environments for training as well. And for the purpose of this course, we will use MakeML. And MakeML just a very good option for beginners because it has data labeling capabilities, and you can start training your model in just a few clicks. So let's see how we can set up it. All we need to do is to press download button. You in the Mac App Store, press download. MakeML has some plans for annotation of images and training of them, and will provide a 50% first month's discount at the end of the course. So right now we need to log in or sign up. We can also continue with Facebook. And we are ready to go. So here we see projects pane. Right now it's empty. Here we can create a new dataset project. Here we can create a new MakeML project where we can like label a dataset and then start training. And here is this quick access to trainings. Also, we have several menus here. We have preferences like subscription information, account information, discount, coupons, contact us, Windows help, everything here. To see the whole information about MakeML, you can open documentation page on the website. But we will look at every needed feature to train actual neural networks further in the course. Thank you. Bye. Hello, it's Alexei, and in this video I'm going to show you how to create your first object detection dataset with bounding boxes. First of all, we need to open MakeML and press Create a new dataset project. Here we need to enter our dataset name, which will be dogs. Here we can select a dataset type, and we need object detection for this video. Let's press Create. Here we press Close button. So first of all, we will need some images of dogs to add to our dataset. I've prepared 3 of them. Here we can just drag and drop, and we are almost ready to annotate them. Then we need to add annotation title, which will be dog. And here we can select a color of annotation title with which we will annotate these images. So I'll select this blue one. So we can add annotation by clicking and dragging. So we can edit them by dragging these circles in the left bottom corner and right top corner. And we are done with these 3 images. We also can change color of annotation title, and all our annotation colors will change. We also can change the color of this cross that helps us to understand where to start annotating an image. So we can, with this one, we can see better in dark positions of an image where we are. Here are 3 sliders. We can change brightness here. Here it is contrast of an image. Sometimes it can be very helpful if you can't see some edges of an object clearly, and these sliders, they are not they don't affect image colors or anything. It just helps you to annotate your dataset, and this is for like opacity of the annotation box. So what I wanted to show you next is import frames from a video. I have prepared one, docvideo1.mov. We can select number of frames that are completed per image. So maybe in this video it will be 10. Then you can press import. The video is processing, and at the end we have 15 more images that we can annotate. Then I wanted to show you one more interesting capability of MakeML, which is import datasets. So first dataset that we will import, which will be dataset format in to recreate format CSV. We need to select images. We will select docs datasets, docs CSV dataset, and images and annotation files. We need to go here and select CSV file. Press import. Yeah, and we have 2 annotated images here. So we can also import dataset in Pascal VOC format in XMLs. So docs datasets, Pascal VOC, we'll select images and annotation files, and import these images as well. Also, while we are importing dataset, we can select whole folder of images. So doc dataset images, open, and annotation files. Cocoa annotations, open, import, and we have two more images here. So our dataset almost ready. We can label these 15 images from the video right now. A few more. So if we have some very similar images, we can delete them and make multiple selection with command button and just delete them. We also can have multiple annotation titles. For example, if our dataset will contain cat, like we add annotation title cat, and we can add annotation like this, and then we can select between annotation titles using command +1 and command +2. We can also switch between annotations on this image by using option +1 and option +2 option, and we can delete them when they are selected by pressing backspace button. So we have created our first dataset and we are ready to export it. We have 4 different formats to which we can export our dataset for further use. Here is some augmentation settings that we can apply, but we will take a look at them a bit deeper in the next videos. Press export, select a path where we need them to export. So let's save it on desktop. So here is our newly created dataset. Hello, it's Alexei, and we have already created object detection dataset with docs. So it has 20 images. Here, dataset, object detection. Let's open it. And in this video, I want to show you different formats to which you can export dataset using MakeML. So we'll press export, like to create CSV. It will be ready to use in to create framework to train object detection neural networks. So we have here augmentation settings. We'll skip it for now. Export docs dataset CSV, save. Here it is. Export dataset Pascal VOC in XML. Docs dataset Pascal VOC, save. Export dataset JSON, export JSON, export. Here it is. Export dataset. Nice doc here. JSON create ML save. So let's close MakeML window for now. Open docs datasets CSV, which is for tool create framework, and in this folder we have images folder with all of our images and annotations CSV file. We can open it with numbers, and we here have full path for this image and annotations here. It has a label dog, type rectangle, and coordinates of our annotation. And for every image, we have these annotations here. Let's look at the next dataset format, docs dataset Pascal VOC. Here we have two folders, all images here and annotations here. You can open annotations like docs0.xml. So we have here like annotation folder images. So it will be in this folder, this image. The name of the image is docs0.png. The size of the image, it's not segmented, and we have an object here with the name dog. We don't have all this stuff like pose, truncated, occluded, difficult, and bounding box. Here we have in a format like xmin, ymin. In like previous format we have like x, y, and width and height. So let's look at the following format, which is COCO format, which is also very popular. Here we have all our images, and here we have annotations in JSON format. So here we have like three arrays: array of annotations, array of all images, and array of categories, which is our annotation title. So array of images, we have an ID for image, the dimensions, and file name. Also we have categories here like name dog and ID, this ID. If we will have some cat, we'll have name cat and different ID for it. We will need them further to understand, like here is whole set of our annotations. This annotation has its own ID. Is it segmentation? No. Like is crowd? No. An area of it, because it's bounding box and we can count this area. Category ID, this is our like annotation title ID for a dog. Image ID 0, which we also can find the correspondence and understand which image name it is for, and our bounding box like x, y, width, height. So let's close it. It was first JSON format in COCO, and here is a dataset for using in Creating ML app by Apple. Here we have all images and annotations file in one folder. So all images here and annotation JSON here. This is just an array which has object annotations and array of these annotations. Here we have label dog and coordinates for it. And this is for all our images. Label, name, and coordinates. And then we have image file name and next annotation. So here it is a brief overview for dataset formats that you can export using MakeML app. Thank you. Bye.
Hello, it's Alexei.
In previous video we have covered how to create an object detection bounding boxes dataset, and in this video we'll cover how to create polygon semantic segmentation dataset. So we have opened MakeML app. We need to press Create a New Dataset project. We need to enter like ball segmentation dataset, select dataset type semantic segmentation, and press Create button. So here we have our plans for MakeML. To start annotating images, we need to import images at first. Definitely, we can do this by drag and drop, or also by pressing Import Images button and select them like this. Open, and we are almost ready to go. We need to add annotation title, which will be bowl. Select color for this annotation title. Let it be this one. So we can start adding annotations right now. We need to press left button and like this. We can open it full screen. If we understand that we made like wrong point, we can press backspace and continue further. Also, if we understand that we have made like wrong point here, we can correct it and proceed. To end editing this polygon, we need to press return button and it is ready. If we have started to add annotation and we understand that we don't need it, we can press escape and it will be gone. So we also can change, as in previous video I have showed, contrast of an image, brightness. We can change opacity of our annotation as well. We also can delete this annotation like this. So, and just let's annotate all other images. And this one. So right now all images have been annotated, and we can export dataset. Actually, in semantic segmentation right now we don't have capability in MakeML to import dataset, but we can export it. We don't have any options for the format how it will be exported. So we just can select augmentation settings. So it has some color changes, some transformations and cropping. So we can just export and let's see what it be. So we are saving to desktop, ball segmentation dataset, save, and here it is. So it has two folders, our images and masks for our images, which is also images. And it seems that they are completely black, but it's not. So we can check it. So here it, for the first image, it's somewhere here. I can open it, and with digital color meter I can show you that these are black, and here we have like 333 RGB color, which is our mask. And for most of algorithms, it is what they need. So in grayscale, we have like 000 for background, and like 333 for the first class. For the second class it will be 666 RGB. For the third class it will be 999, and so on. So we have exported successfully our first semantic segmentation polygon dataset. Thank you. Hello, it's Alexei, and in this video I'd like to discuss the following topic. One of the biggest bottlenecks in training neural networks, one of the most time-consuming tasks, is collecting and processing data. So for creating a good model for object detection, for example, you will need to collect lots of images and then annotate them. And sometimes it is much easier to find ready-to-use dataset. And today I'd like to show you a place where you can find lots and lots of datasets. So Google recently released the dataset search, and right now they have indexed more than 2.5 million datasets. So these datasets are not only computer vision or like object detection or semantic segmentation. They are very different. So it can be just table data, it can be some maps, it can be just raw data. But you can find lots of useful dataset that will save you tons of time. So let's search for some object detection dataset. Detection. So we have quite a few datasets here. So let's select GAN's object detection dataset. Here is like 4 datasets from Kaggle and some more. So we can, for example, select this one and press Explore at Kaggle. They don't provide like links to download it right at the search. You need to open a web page that Google have indexed, and somewhere here will be a link to download. So at Kaggle you can download it from here. You need to just register, sign in, and then you'll be able to download. At Kaggle you can see like how data looks here. So it has weapons folder which contains train labels.csv and images. So they have 3,000 images and train labels. Yeah, and so from MakeML there are some datasets here at Google search as well. One of them is fish object detection. Let's search for it. So here is fish dataset from MakeML. So it has like license here. It has description, dataset type, object detection. It has bounding boxes, includes these types, and we can explore it at MakeML. So MakeML has like dataset store, their dataset store with currently 10 datasets in it. You can find something useful here. And for example, we will take fish dataset. To import a dataset, you need to install MakeML at first. And if you have MakeML app installed, then you can press Open in MakeML app button, and it will be imported into new project. So it has some description here. Object detection dataset includes these types. It has 737 images, so you can see license here for this datasets at Creative Commons. So when you press Open MakeML button, it proposes you to open the link in MakeML. We press Allow, and it proposes you to create MakeML project from fish dataset. Fish project, object detection dataset type. We can select training configuration here, let it be TensorFlow, press create, and it starts downloading dataset. Yeah, so Google Dataset search can save tons of time for you. For example, if we have seen a GANs dataset that has 3,000 items, and you will need like a couple of persons that will annotate it for a couple of days, and yeah, and you can find something useful there. It's not every time in the good format, or it's not every time really what you need. Or like quality can be not very good, but to find some images or like for proof of concept, it can be very, very useful. So the last step for importing dataset. So it has like 13 classes different, and 700 images, and we can change batch size, number of iterations, and we can run this training. So thank you. That was an overview of Google search for datasets and MakeML dataset store. Thank you. Bye. Hello, it's Alexei, and in previous videos we have created several datasets, like 2 datasets, docs and ball segmentation datasets. And in this video I'd like to show you augmentation capability of MakeML, and I'll tell you a bit what it means. So we have this project with annotated images of dogs, and when we press export and select any dataset format we want, then press export, we here have augmentation settings. And what augmentation actually means for us and how it can help us. So when we are trying to train neural network, we need to provide a lot of different situations and for our neural network, so it will be able to see different situations and try to find something in common, and actually understand these features and understand how actually this dog looks like. And if we, for example, crop an image from the left and crop from the right and crop from the top a bit and crop from the bottom a bit, it will be like original image and these 4 images will be completely different from the perspective of neural network, and it helps neural network to train better. And if we select all of these, like random crop left, right, top and bottom, we'll receive, like we have originally in our dataset 20 images, and right now we will have 100 images because 8 images will be created. So the next option, transform. Transform actually rotates images like left, right, upside down. It has vertical flip and like in mirror, and horizontal flip. Like if we are trying to learn a model to detect dogs, I think it won't be very useful for us if we will like rotate horizon to the left, to the right, upside down, or make vertical flip, but horizontal flip, it definitely makes sense for us. And color augmentation. Here at all images we can see that this is still a dog, but from neural network perspective it's completely different images. So we can select all of these color augmentation options, and we will receive from 20 images, we will receive 2000. So we'll press export. So right now augmentation process is going on. I'll fast forward this video a bit. So yeah, augmentation process took some time, and right now we can save our augmented dataset. Press save. So docs augmented dataset, images. And if we'll select all of them, so we have 2000 images. Let's see what are the names of our images here. So we have right now like docs, augmentation, horizontal flip, and here after we made horizontal flip, we also apply low contrast because it's like 2 different images, and low contrast, low brightness, or like we crop an image and then make horizontal flip and make it in black and white. And all of these combinations, all of them are different, and it helps our model, it will help our model to train better in future. So here we also will have all of these like new images here, and labels will be also augmented for it. So it's a completely new data set. Let's close this project. Open ball segmentation. Press export dataset, and we can also here select like different augmentation types, press export, have some augmentation here. This dataset is it's not so time consuming because we have only 3 images here, and at the end we will have 900 images from it just by applying augmentation. What I also need to say, like, why we need cropping, you may ask, because like features are the same. We need cropping because model expect objects to appear in the same position on the screen. It better understands if an object appears in the same position. So it's better if our object will be in our dataset at different set of positions. So here we also have like both segmentation, like different like contrasts, different crops, rotations, etc. And you can see here that also we have very like different images in terms of color, rotation, and so on. So thank you for watching this topic. Thank you. Bye. Hello, it's Alexei, and in this video we will talk a bit about training parameters. So we will create 2 test projects. One will be for object detection TensorFlow. Object detection. And training parameters are here in this tab, and you can change batch size and number of iterations for a model in object detection TensorFlow model training. So batch size actually it is a value that are set in number of images that are taken into account at every step of model training. So basically we have a model structure, and a model are trying to predict at, for example, if batch size 24, at 24 images, it tries to predict bounding boxes for objects on it. And then it receives some errors. And we know also true values that need to be there, because we have our data set labeled and we know correct values. And it looks at mistakes and taking into consideration 24 images, trying to minimize neurons of our model to get better value. So these 2 parameters mean that we will have 2000 iterations, and at every iteration we will take into account 24 images when we will train object detection TensorFlow model. So we can change these parameters. For example, if we understand that we don't have enough quality for our model, and our loss on our graph is always going down while training, we can try to increase number of iterations. And if we see, for example, that it's like when the model starts training, loss is going up from the very beginning, we can try to decrease batch size. If we see that like we set number of iterations to 20,000 and we see that at the beginning loss is going down and then it's going down, is going up, then we need to try to find value a little less. So to achieve as better loss as we can. So in and right now we will create a new MakeML project with TensorFlow semantic segmentation, and I'll also will show what parameters we have there. Semantic segmentation, TensorFlow. Great. Here we have also batch size, number of iterations. We can change them. It's also we can change them as in previous model, and they are responsible for the same purposes. And here we also have base learning rate. And base learning rate actually is a value that that says to us how fast we want to train our model. If it will be very big, so then it can miss, it can't be very precise at the very end. But if it will be very slow, then we can't get to a reasonable good values at the end. So sometimes if we see that our loss is going up, then we maybe need to try some to increase or to decrease base learning rate. Maybe we need to increase 2 times number of iterations and decrease base learning rate 2 times, and then we will have much more precise model at the very end. So basically nobody knows best hyperparameters for a dataset, and you can just try different values, and also if you have some questions, you can contact MakeML team and ask some advice and questions how they can help you to improve your hyperparameters and receive better value for the model. To recreate, as I've mentioned in previous video, you don't need to set any hyperparameters. So the framework that are training the model sets them by itself. That's all that I wanted to tell you about changing hyperparameters and what you can change to improve model quality. That's it. Bye. Hello, it's Alexei, and in this chapter we'll create our first project called Dribble app. Dribble app is an iOS app that detects the number of touches of the soccer ball. We'll use an object detection neural network that detects the soccer ball trained on ToRecreate framework. In this video, I'll show you what dataset I've used and how I collected it. So you can find this dataset on MakeML app/datasets here. This dataset has 182 images, so it's annotated with soccer ball with bounding boxes. We can press open in MakeML, enter project name, we'll call it Dribble. Dataset type will be object detection, and train configuration will be to recreate. I'll press create, and right now it's downloading, unzipping, and importing. I've created this dataset in less than 2 hours. Around 30 minutes, I was walking around my apartment and taking pictures of the ball, and then around half an hour I was annotated all these images. So you can see here that that every image that I took is not the same as previous one. The ball here is in different locations on the image. Uh, it is on different backgrounds, and it helps a model to train much better than if it will be on almost the same location, on almost the same background. So it was done on purpose. And after we have imported images and annotated them, to recreate, we can just press train button, select augmentation settings. I'll select all crop settings, then I'll select horizontal flip, because vertical flip and rotations will not be very useful for us, because we'll see only in one orientation the ball in further. And I'll select all color augmentation options, but here we have 18,000 images, and MakeML has a limit of 15,000 images for the dataset. So we'll unselect black and white and contrast minus, brightness minus in color augmentations, and we have almost 15,000 images, but a little bit less, and we can start training. So this process will take some time, and in the next video we'll start from the moment when the model have been trained. Hello, it's Alexei, and in this video we looked at results of model trained on our dribble dataset. To look at it, we need to press train or window trainings, and we see here our model training. The loss is going down, so everything is okay, and at the end we have a loss of 0.3, which is pretty well. We need to export model right now. So the results are downloading, and we can save it to our desktop. So it's here. So we can close MakeML for now and open MakeML app GitHub. So here is a project, Live Object Recognition CoreML. So which actually a place where we can download this app, change our model inside, and run it on our mobile, and we'll see the results of the model. So we'll press clone and download zip. Actually, it took some time, and I have downloaded it already. And we can run Xcode right now. Here we have ML model file, and we need to replace it. So actually I'll delete it. Move to trash. Unzip results.zip, then open it. Here we have ML model. Import it to a project, and here it has capital M, so ML model, and we can run it on our iOS device. Here, here we can see how our model is working and how it is detecting a soccer ball. In these files, it is logic on running this model, and we'll talk in the next chapter how we can process this data and what everything here means. Hello, it's Alexei, and in this video we are gonna talk about Dribble app implementation of touches detection. So we have modified object detection livestream app, so right now it's able to detect the number of touches of the ball. I'll start with setup vision method in object detection view controller. So first of all, we got compiled CoreML model URL. Then we instantiate vision CoreML model. So vision model equals try vision CoreML model from this URL. Then we instantiate vision CoreML request, and we store it in self.requests. We also set up capturing output from the camera, and every time, like every frame that camera captures the output, we got here, and we have here image request handler, which is vision image request handler, that perform our requests. When this image request handler perform all of our requests, which is array of vision CoreML requests, this method in Clojure calls. So every time we got a new frame, we run this code. So here we need to go to this method to see what logic we have in here. So every UI stuff in object detection livestream we have in CI layer. So we begin CA transaction and we commit CA transaction at the end of the method. So we remove detection overlay from the very beginning. We will add this detection overlay if needed further. So we got some results here. If we have some results from vision CoreML request, then we will draw vision request results. So we have observation here, and if we have them, then we proceed to this part. So we got a normalized bounding box here, and here we have bounds in points without normalization. We have added like horizontal center of the ball array, and we append every object bounds center to this array. So right now we will try to detect number of touches by comparing these values and understanding if our ball was going to the left and right now it starts to go to the right, then we'll detect it as a touch, because if we are training dribble, every touch of the ball will get us to changing of the direction of the ball movement. So we count number of touches in this method. So every time, this can be of course optimized, but for the purposes of demo we keep it simple. So we set number of touches to 0, we set moving left property, and we set ball center value here, and we are going from through the ball X center array, how we call it. So here we store all center positions, horizontal center positions of the ball, and we detect if it was moving left and start to move right, then we add number of touches here, here and here. And we change, of course, moving direction in this Boolean value, moving left, false, and true. And we set ball center value here. So after we have got number of touches value, we update our labels, like label with number of touches here, to show the ball overlay, which is like green circle. We use this method. So we need to create a CA layer here. Of course, our detection of the ball will be a rectangle, because we are working with object detection, and it always has as an output rectangles. So first of all, we want to understand here what dimension is bigger, width or height, and we take the biggest dimension. We take the biggest dimension and working with it to create UI Bezier pass and pass and circle pass, and we can make with it a ring. Let's look how it works right now. Running the project, and right now we are starting the session, and we see here that timer is running and number of touches going up and up here. So we have just added around 100 lines to our basic project, and we can understand if we touch the ball and how many touches we make. Hello, it's Alexei, and in this video I'd like to tell you about the case of PepsiCo, who uses computer vision to sort potatoes by weight. So they have created computer vision scales, and so we'll start to make a project here which will detect potato weight. So for this project we will need not one dataset but 3 datasets. That's because we couldn't achieve good results from the very beginning, and I'd like to show you what we have done and what datasets we use to actually create a model we need that will detect and segmentate potatoes. Great. So our first attempt was to make 61 images of potatoes in different conditions. And as you can understand, it didn't work out great. So after it didn't work out, and I'll show you what was actually the best results for the models with these 3 different data sets in the next video. So our second data set was potatoes on only white paper, because we were laying white pieces of paper under potato and laid it on actual scales to validate if our app works correct. Here we also have a problem, because we have almost the same screen on our electronic scales. And our last data set, which is called potato final, it contains this screen of electronic scales. So on this data set, it can understand that this is what we need and this is not, because actually, if we'll see, they're somehow similar by color with this stuff, and model was added by mistake sometimes. So here was a brief overview of datasets that we use for our potato scale project, and see you on the next video where I'll show you our training results from these datasets. Hello, it's Alexei, and in this video I'd like to show you how we have trained a model for our potato scales app. So we have trained around 20 models before we got something reasonable as a result, and I'd like to show you like 3 model trainings that we have with hyperparameters, what we have got as a result as our model, loss graphs as well, and yeah, so to start training, we just need to come here, open a project, select hyperparameters that we need, and press start button and select augmentation. So that's simple. After this, model uploads, and the model's dataset uploads to the server, and the model training starts. So in our first attempt, where we have 61 images and all augmentations were enabled except black and white and contrast minus, brightness minus, we have received this result. So here we can see just small dots, small yellow dots. It's actually what our model is detecting, and it's definitely not what we expect from it. And we have a graph like this. Here is our hyperparameters. We have 10,000 iterations, batch size was 4, and base learning rate was 0.00001. So it was made with a dataset that has 61 images of potatoes on different backgrounds. So it doesn't help, and we understand that we need something similar for model to understand. It's very hard to find a pattern between these images and understand where is potato. So we have tried we have created our second dataset that consists only from potato images on just white background, and we have got this result. So we understand that here is our potato, but we also detect screen of our scales, because we have just like these just this area on our images, and it thinks that it is very similar to potato. The screen of our scale is very similar to potato. So for it we have just 11 images, and we have only contrast plus, brightness plus, contrast plus and brightness plus, augmentation here. Images with only white background were used here, and here you can see our loss graph. Loss graph is not very different from our first attempt, so we cannot see that it goes something in some other way, but it detects something definitely. It has mistakes, but it is much better. So loss, not every it's not every time that loss is good for evaluating of your model. Sometimes you need to just export model, run it on your mobile, and test it. So after we have this bad result, we understand that we need to make images with the whole area and only label this area with potato on it. So at our successful dataset, we have 15 images that are made like this. Here we have scale screen, and here we have potato, and we have annotation here, and we don't have annotation here. So let's look what we've got at the end. So right now it's showing 0 and 165 and 160, 150, 170, something like this. Yeah, so that's what we need. And another potato is here, and it has 187 here and also 185 here, something like that. So loss graph here, it's not something better or worse than other graphs. We have here 2000 number of iterations, batch size was 8, and learning rate was 5 divided by 10,000. So we have used contrast plus, brightness plus, contrast plus, and brightness plus, random crop, horizontal, vertical flip, rotations, and that's what we use as our augmentation here. And yeah, on these images we have end potato and screen of the electronic scales on our images. That was a video about how we have trained a model to detect potato on an image, and in the next video we'll tell how we create an app that runs this model and says to us what actual weight of the potato is. Thanks for watching. See you. Hello, it's Alexei, and in this video I'm going to explain you how we count weight of our potatoes. So you can download at GitHub MakeML app potato scales an iOS project, and when you run it you'll see something like here. To use your model inside this project, you need to replace result model.tflight with your model. And we have a logic that counts the weight of our data in viewController.Swift. So we have a property here called coefficient, and I'll show you in a minute what it means and for what purpose we use it. So we process every frame, and we get result from our model, and we have some pixels that our model predict to be potato pixels. So we have this property colored pixels count, so it has model last coordinates count. Last coordinates is from last prediction, all coordinates that actually have our potatoes in it. So if it's array, so we may just count, and we understood the area of our potato on an image. To get a weight of our potato, we need to multiply volume of our potato on our density. So we have area of potato on an image, and we need to make a square root from it to get our linear like dimension of our potato. Then we poll it into poll by 3, and we got a volume of our potatoes that we need to multiply by a coefficient, and we will receive weight of our potato, and then we just update a label on our screen. So that's how it works. Thanks for watching. Bye.